Welcome to Summarize Science, where we break down the latest breakthroughs in technology. Today, we are looking at a new method called GiVA that makes training large AI models much faster and more efficient. As models like those used for chatbots continue to grow, teaching them specific tasks becomes incredibly expensive and slow. Currently, researchers use parameter-efficient fine-tuning to avoid retraining the entire model from scratch. A popular method called LoRA is the standard, but it still requires significant memory and training time. Other, vector-based methods were invented to be even smaller, but they usually perform poorly unless they use a lot of complex data. The researchers behind this paper noticed that these smaller methods were struggling because their starting foundations were random or poorly chosen. This led them to ask if they could reduce the complexity while keeping the performance high. Their answer is GiVA, which stands for Gradient-Informed Bases for Vector-Based Adaptation. Instead of picking a random starting point, GiVA looks at the very first step of the training process to see which direction the model needs to learn. They use the gradient of this first step to set up the mathematical foundations for the rest of the training. By doing this, the model starts with a much better guess of how to adapt to its new task. Technically, they use a process called singular value decomposition on that first step gradient to find the most important parts of the data. This allows the system to focus only on the information that actually matters for the specific task at hand. Because the starting point is so accurate, the model requires much less rank, which is a way of measuring mathematical complexity. They tested GiVA across many different benchmarks, including natural language understanding and image classification. In these tests, GiVA consistently matched or beat the performance of older, more complex methods. The most impressive part is that it did this while reducing the internal complexity by a factor of 8. Looking at the data tables for common language tasks, you can see that GiVA holds its own against full-scale fine-tuning. Even when using significantly fewer trainable parameters, it remains competitive with the industry-standard LoRA. This means you get the same smarts with much less digital baggage to carry around. The researchers also applied this to vision models, showing that GiVA is not just for text-based AI. In image classification tasks like identifying flowers or food, GiVA achieved high accuracy with very low overhead. This versatility suggests that the method can be used for almost any type of AI model. One of the biggest wins is training time. As models get bigger, GiVA actually gets faster compared to its competitors. For very large models, GiVA is significantly quicker to train than other vector-based methods because it handles data so efficiently. This solves a major bottleneck in AI development, making specialized training accessible to more people. To recap, the researchers developed GiVA to fix the slow training times and high memory needs of previous AI tuning methods. It works by using the first step gradient to set an intelligent starting point, allowing for an 8x reduction in complexity. This results in AI that is just as smart but much easier to store and quicker to train. In the future, this could mean that highly specialized AI models could be trained and run on your smartphone or personal laptop. It reduces the need for massive data centers for every single task, making AI more sustainable and private. Thank you for watching Summarize Science, and stay tuned for more breakthroughs in the world of tech.